In this video, we're going to be talking about increasing and decreasing functions. All right. In a subsequent video, we'll talk about local maximum and minimum values. All right. So what we want to do here is we want to determine the intervals over which a graph is increasing, decreasing, or constant. So let's define those three terms in this context first. All right. So a function is said to be increasing if, as you read the graph from left to right, which indicates the x values are getting larger, the graph is going up, which means the y values are getting larger. So if you look at this, over this linear piece right here, this is a piecewise function. This first piece is linear. Notice as we move from here to this point, the graph is going up. The y value is getting bigger. So this interval would be considered an increasing interval, or the function is increasing over this time, okay? Decreasing function, as you read the graph from left to right, the y values are getting smaller. Now, this function only has one area or one interval where it's decreasing. From here to the origin, that's the only time the y values are getting smaller, okay? So from -1 to 0 here, the function would be decreasing. We'll go over that in more detail a little bit later. And a function is said to be constant if, as you go from left to right, the y values stay the same. So that would be a horizontal piece. So it's going to be, this function is said to be constant from 2 over here to the end of the graph. Okay? So let's answer those questions in a little more detail because we didn't go over all the intervals that are part of the function just yet. Okay? So over what intervals are the graph increasing? All right, so again, we're going to say this is at -6, and we're going to say the graph ends at 7 here. There aren't any arrowheads suggesting that this graph continues indefinitely left and right. So we're going to say the graph stops with what you see here. So the first interval that we're increasing from -6 to -1, notice the graph is increasing over that time as we read from left to right. So the first interval for increasing is going to be from -6 to -1. Okay? Now, if you'll notice again, we talked about over this interval, it's said to be decreasing. And then once we hit the origin, notice the graph turns back to increasing. So from 0 here to +2, we're also in increasing with this function. All right. B, over what interval or intervals is the graph decreasing? Now, we've already kind of answered that question. From -1 to 0 here, notice the function is going down. The y values are getting smaller over this short period of time. So the only place this function is decreasing is from -1 to 0. Okay? C, over what interval or intervals is the graph constant? And you can see here at 2, we've got, this is called a removable discontinuity or a jump. So the graph kind of jumps from 2, 4 down here to what we'll assume is 2, 3. And at this location, notice the graph becomes horizontal and the y values stay the same until the function ends here at x equals 7. Okay, so we're going to consider the interval, we're going to consider the function to be constant over the interval from 2 to 7. Okay, domain, remember domain is what values of x are present. Okay, what can x be, what can x not be? We've talked about that a lot. So this graph moves from -6 on the left to 7 on the right. All values are present, even this value at 2, even though there's an open circle here, 2's present at this closed point here. So the domain is going to be the values from -6 to +7 inclusive. We're including both -6 and 7 in that domain. Okay. Range is going to be the values for y. So the lowest value here is -4. And the highest value is up here at +4. There's no gap where there's other y values that aren't present. So we're going to make it the interval from -4 to 4, inclusive. All of those values are present. All right. List any zeros. Okay. Zeros is just another name for intercepts, x and y intercept. You're going to start to see the term zeros more often as we progress in the class. Okay. So we've got an x-intercept here at -2. Okay, we've got another x-intercept here at the origin. And because the x-intercept's at the origin, it means we automatically have a y-intercept at the origin as well. Because it's a function, it can only have at most one y-intercept, so we don't need to search for anything else. Okay. So the priority here was increasing, decreasing intervals, but we wanted to review some of these other terms as well. So that's how you determine when a function is increasing, decreasing, or constant.